Welcome everyone. In this video lecture, we will solve a GATE 2007 question in which we have to find the mode of operation. So in the circuit, BJT circuit, it is given beta value is very high and VB value base emitter voltage is 0.7 volt. So we have to identify the mode of operation. Okay, cutoff saturation, normal or reverse active. Okay, so this one is the circuit. So one can read redraw the circuit. Okay, this one is our 1 kilo ohm, this one is 10 kilo ohm, and this one say 10 volt, and this one is 2 volt. Okay, and the given things are beta value beta value very high. What it means? As we know, IC equals to beta IB. Okay, so IB value equals to IC by beta. So here the beta value is very high. Okay, it may around 200 or 500, 100. So IV value is negligible and it is considered 0. For a high value of beta, for a high value of beta, I am just highlighting. For a high value of beta, we have to take IB value 0. Okay, so now for for the mode of operation, okay, so for the mode of operation we have to know some facts. Okay, so this one is very important. Base emitter junction, I am writing here base emitter junction and base collector junction. Okay, that we have to know. Okay, and here we can write operation. Okay, so if operation is our active region, okay, active, so base emitter junction will be forward biased. Okay, forward biased, and this one will be reverse biased. Okay, for the active region. Now for the saturation, for the saturation region, it should be forward bias, base emitter junction, and base collector junction will also forward biased. Okay, now cutoff. In the cutoff one, both junction will be reverse biased. So that we have to know. Okay, reverse biased. If and reverse active, one more thing. Okay, reverse active mode, reverse active. So it should be reverse. Okay, and it should be forward bias. If you know this thing, it will very easy to solve such question. Okay, I am putting it in a table format. Okay, clear? So this one we have to know. Okay, this table for any operation, if question comes in which one the circuit is operating. For example, active mode. So VBE will be positive for forward bias, and VBC negative. Okay, for active. For saturation, VBE positive and VBC negative. So that thing we have to determine. Okay, for cutoff, all will be reverse bias, so negative or reverse active. reverse base emitter junction reverse bias, and this one. So this one is the theory. Okay. Now we have to go for the this problem. So now already given IB value is 0. Okay. So now what we are doing, this one is our base in collector and emitter, and this value is VBE 0.7 volt. Okay, 0.7 volt. So if we apply Kirchhoff's voltage law in this loop, say loop 1. So if we apply KVL in loop 1, we will easily get the value of IE. And here we can say IB is 0. So IE is nothing but simply IC. Okay, IE is same as that of IC. Both will be same. IC equals to IE. Okay, so IE we can easily find from this one because IB is 0 for a high value of beta. So what we have to do, we have to write KVL, Kirchhoff's voltage law, in loop 1. Okay, so KVL in loop 1. So what we can write, just simply apply KVL to minus VBE, okay, minus IE, and that resistance say RE, okay, equals to 0. So one can write IE RE equals to 2 minus VBE, or we can write 2 minus 0.7, or we can write 2 minus 0.7, it should be 1.3. So IE value is nothing but simply 1.3 divided by RE. RE. Okay, I am once again writing. Then it should be 1.3 divided by RE is 1 kilo ohm. So it should be 1.3 milliampere. So our IE value, once again I am finding 1.3 milliampere, which is same as that of IC because beta value is high. I am highlighting this one because beta value is high for beta high value. Okay. So now IC is known to us. Now I have told earlier that for any operation we have to find VBE. So VBE is already 0.7. So this one is positive value. So we can say this one is in the forward bias. Okay. Now the next one we have to find VBC. Okay. It means VB minus VC we have to find. Okay. It is clearly here the VB value is 2 volt. 2 volt. 2 minus VC. Here this VB is 2 volt because this 2 volt is connected to base it. So VB is simply our 2 volt, 2 minus VC. So the unknown is our VC. If we know the value of VC, then we can say what is VBC, positive or negative. Okay. So what we have to do, we have to find this VC. Okay, this VC. Okay, now IC is there. Okay, so once again I'm making one small circuit. This one is 10 volt. Okay, and this one is 10 kilo ohm. IC value already known to us because this one is IE, and this one we have to find VC. Okay, so what we have to do? Simple KVL we can apply, or directly we have to find this IC value. So this IC value we can write as IC is nothing but simply your IE is given higher potential 10 volt minus VC divided by, let's say, RC. This one is our RC. So it will be 10 minus VC. Okay, I am removing V term. RC is our 10 kilo ohm. Okay, and this one is nothing but simply IE is same. So it should be 1.3 milliampere. Okay, So one can easily find the value of VC. So I am writing 10 minus VC equals to 1.3. Okay, 10k into 1.3. Okay, 1.3 into 10. Okay, into 10 to power 3, or milli, for the milli we can write 10 to power minus 3. Okay, you do a step by step. And if we remove, it should be VC. So 10 minus VC equals to 13. Okay, so we can write the value of VC equals to 10 minus 13. So it should be minus 3 volt. So VC value is minus 3 volt. We have already find the value VC equals to minus 3 volt. Okay, I am highlighting this one because this one is important. VC we need. Okay, because we have to put here. So what next we can write? Okay, sorry. Now we can write, I'm taking blue color. 2 minus VC value is minus 3. So minus 3. So it should be 2 plus 3, 5 volt. So now VBC is again positive value. VBC is positive value, and VBE, base emitter voltage, is also a positive value. Okay, so when both base emitter junction and base collector junction is positive, so we can say this one is in the forward bias. Okay, both are forward bias, so it should be in the saturation region. So we can clearly say this one is in the saturation region. So it is very simple question. Okay, so we can easily say this is operating in the saturation region. Okay, so what we have to know, this one active both base emitter junction forward bias means BBE positive, BBC negative. Okay, for active, for saturation VBE positive, BBC positive. Okay, so we have calculated and we have find VBE 0.7, so it is positive. No need to calculate so many things. Okay, VBE positive. Okay, now for VBC we need VC. Okay, for VC we have taken this one 10 volt, this one, and VC. So 10 minus VC by RC is nothing but simply IC equals to I, because beta is high, so collector current is same as that of emitter. So we can easily find the value of VC. So VBC is again positive. So both are positive, VBE positive, VBC negative. We can say this one is in the saturation region. Okay, so this is all about this question. So thank you for watching this video.